So, I was talking about hydrated and anhydrous. Are we together?
Yes.
And I said, I was giving a certain text in the Bible that somebody, I think it was a prophet, who was directed by God, that go to where bones are, then instruct them. Ezekiel, are we together? Yeah, then I now admit and acknowledge that I'm in a school where people worship every now and again. So that is why, and who can now take me the verse now? The book of Ezekiel. But we do a research of that. Are you together? Chapter? That everybody, when you are doing a song. So there, God is instructing Ezekiel to go and preach gospel to them dry bones. Dry, the term dry is an English term. So let us assume that God was using a chemistry term. God could have used this term. Go and talk to anhydrous bones. To mean something that is anhydrous is dry. It has no water. Are we together?
Yes.
I am. Let's come to hydrated. Hydrated. Let's assume that you take a soil and close it with a lid. Then you start heating for maybe for 30 minutes. Then you remove that lid. What will you observe on top of that lid? Water. And you place a dry soil inside it, then you close, then you start heating. What will you observe here? Water droplets. Water droplets. Are we together? So where are these water droplets coming from? Inside the soil. Are we together? So to mean, we can say soil has got water of crystallization. Crystallization. So anything that has got water of crystallization is called hydrated. And one that is dry, that has no water of crystallization is called anhydrous. Well understood? Yes. Well understood? Yes. Promise. Yeah, very good. And by the way, I forgot to recommend on your good work. You did a very good job. Mtu alikusaidia? Ulifanya peke yako? Okay, it was wonderful. So, we will be talking about hydrated and anhydrous solution. See, we know what is meant by being hydrated. We say hydrated has got water of crystallization. Anhydrous has no water of crystallization. So let us use one example here. We have got hydrated copper 2 sulfate. Copper 2 sulfate. Hydrated copper 2 sulfate. You heat it. Number one, we say in temporary, the substance remains the same. Are we together? Now, who can tell me? It is hydrated. It has been heated. It will change to anhydrous. Copper 2 sulfate. And why is it now hydrous? There is no water. So there is water here. Plus water. Are we together? Plus water. Water has been removed. So it remains anhydrous. Are we together? It was hydrated. Hydrated to mean it has water of crystallization. It has been heated. Water has separated. It has remained what? Anhydrous, a dry one. But now, this one, it is blue in color. Blue in color. And this is the color of somebody here. It is now white. Who is called white? Oh, James is. It is now white. So we say if it is hydrated copper 2 sulfate, it is of which color? Blue. And if you heat it, it changes to white. And there is a production of water. Well understood? Yes. Boys, are we together? Yeah. Now, if somebody asks you the chemical test of water, if somebody asks you the chemical test of water, and we know very well that in temporary it can be reversed. If you cool it, if you make it, is it cooling? Yeah, it can be reversed. Cooling means there is you produce another water, then it will change to this. So if somebody asks you the chemical test of water, chemical test of water, what will you say? The chemical test of water. Now we are coming backward. We are now starting with anhydrous copper 2 sulfate. Are we together? When you add water, maybe if there is a water inside the container, then there is this water. Then you want to confirm. You are not sure if this is water. If you add anhydrous copper 2 sulfate, it will change to? What will it change? It was anhydrous. First, let us now know what if, before we think of the color, it was anhydrous copper 2 sulfate. You've added water. It will change to? Which color? Blue in color. So if somebody asks you the chemical test of water, you will say it turns, and maybe you can talk of addition of water. Turns. I want you to tell me what I want to write. It turns. It turns. No. I want you to mention everything. It turns when you add water to what? Anhydrous copper 2 sulfate, which is white in color. It turns from white. You mentioned the color anhydrous copper 2 sulfate to blue. Don't forget the color. To blue, hydrated copper 2 sulfate. Now, do you understand the chemical test of water? Do you understand the chemical test of water? It turns a white anhydrous copper 2 sulfate to blue. Are we together? So there are two chemical tests of water. This is the first one. We have got another one here. Another one. If you've been asked the chemical test of water, you write the first one. It is always 2 marks. And I think it will be there in your card that will be on Sunday, if I'm not wrong. So, if you've been asked to give the chemical test of water, you write 2 things. The first one, we say it turns white anhydrous copper 2 sulfate to blue hydrated copper 2 sulfate. Then unaweka tu full stop. Then this color that you started with is what you start with here. Blue and blue. Blue what? Blue cobalt 2 chloride. Blue anhydrous, cobalt 2, chloride 2B. And this thing is now, when you've added water, it turns to, no, I'm talking of the water I was writing, anhydrous and hydrated. When you add water, it becomes hydrated, and the substance will not change. Cobalt 2 chloride. Cobalt 2 chloride. Cobalt 2 chloride. Is that well understood? Yes. James, have you understood the chemical test of water? Now we can write notes. Okay. Now, let's say what happens after writing temporary chemical change? You say what happens when copper 2 sulfate crystals are heated? What happens when copper 2 crystals are heated? What happens when copper 2 sulfate crystals, copper 2 sulfate crystals are heated? What happens when copper 2 sulfate crystals are heated? I think you can you just write your own notes from what we've explained? You can write, but I want to give you. It is like we are just, you make sure that as I will be dictating, you recall. Are we together? So there is a diagram here I'll expect you to draw, and I'll check. There is a diagram here. Then after leaving a very good space for that diagram, say, you need to leave a space for the diagram. A very nice space. I think like, you can leave like 7 lines. 7 lines. Okay, so let's say crystals of copper 2 sulfate, contains water of crystallization. Crystals of copper 2 sulfate contains water of crystallization. I know what I want to do. You say you can write your own notes, from what we've explained. So I'm not be giving everything. Like this one I'm saying, crystals of copper 2 sulfate contains water of crystallization, and it is said to be, then you finish in red pen, and it is said to be crystals of copper 2 sulfate contains water of crystallization, and it is said to be, very good, and it is said to be, there are people that were with me, Daniel, and it is said to be, very nice, and it is said to be, classic. It is said to be very good. And it is said to be hydrated. Are we together? Yes. And it is said to be hydrated. And it is said to be hydrated. When heated, it decomposes. When heated, it decomposes to produce white copper 2 sulfate powder. When heated, it decomposes to produce white 2 sulfate powder, which is you feel which is make sure you are writing the correct spelling. Don't separate anhydrous. Just write it full. Anhydrous. Which is anhydrous plus water. Which is anhydrous plus water. Which is anhydrous plus water. Let us write the chemical equation. Write the chemical equation. I think you can just start writing the chemical equation before writing. Can you write? Huh? Can you write the chemical equation of hydrated copper sulfate being heated to produce anhydrous plus water? You cannot. You can. Daniel, you can write. Huh? You cannot. James, can you write on your own? Promise? Can you write on your own? You cannot. What I mean is here, let us all write this equation. Hydrated copper 2 sulfate being heated to produce anhydrous copper 2 sulfate plus water. Copper 2 sulfate plus water. Then we indicate the colors. This is which color? Blue. Blue in color. Very good, Nani. Remind me of the name? Hassan. Very good. And this one is? White. White in color. So that is white in color. The board behind you. Are you writing? That's it? E. You are not writing. You have good notes. Up to where? Are you done with Form 1? You've written notes up to which topic? Have you started acid-base indicators? Huh? You've copied notes up to acid-base indicators. Okay, so it is only today. Listen to me keenly. It is only today that I'm allowing you to do that. Next time when we are copying notes, you copy with us. Sound? Yeah. Then another equation is in here. Hydrated cobalt. Hydrated cobalt 2 chloride being heated to produce you can even just write heat to produce anhydrous cobalt 2 chloride. Cobalt 2 chloride. Cobalt 2 chloride. We said this one is which color? Pink. And this one is blue. And that one is blue color. Plus water. Don't forget this. Plus water. Okay, now let us write the chemical test of water. Addition, this is the answer. Addition of water turns anhydrous, we write the color, turns white anhydrous copper 2 sulfate blue full stop and blue anhydrous copper 2 chloride to pink anhydrous cobalt 2 chloride. That is the chemical test of water. 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 Are we done with writing the chemical test? Let us write very fast. Let us write very fast. Let us write very fast. It turns white anhydrous copper 2 sulfate blue and blue anhydrous cobalt 2 chloride to pink. This is isolated. Write this isolated. Okay, so I think we are all done. So this process of heating a substance with the water of crystallization and it decompose into an anhydrous compound and also water. This process is called thermal decomposition. Are we together? The process of heating a substance with water of crystallization to produce a dry substance and water. It is called thermal decomposition. Right? Thermal decomposition. Not decomposition, but right? Thermal dissociation. Yeah, it can be thermal decomposition, but let us use thermal not as a subtopic. We want to define it. Thermal dissociation. Thermal dissociation. Then we say dissociation. Then we say this is the decomposition of substance. This is the decomposition of substance when heated. This is the decomposition of substance when heated. This is the decomposition of substance when heated.